lecture we will look at two optimizations, namely hash-based value numbering and global value numbering. But we will start with looking at copy propagation during translation to SSA form one more time. So recall, when we have a copy statement like this, we can remove it and instead simply push the current value of A onto the stack of B. And then when we want to use B, we, as normal, without any special cases, simply take the top of the stack of B and use that as the operand. Okay? We will use essentially the same principle during translation to SSA form, but extending it to not only use copy statements, but to use expressions. So here we have a copy statement, and what we want to do is to have more general instructions in this case. Okay. So what we will look at is an example of a more general optimization principle called redundancy elimination. And an expression is redundant if it has already been evaluated and the values of the operands and therefore the expression is still the same. And eliminating redundant expressions is very important. There are some different approaches to redundancy elimination, and we will look at three of them, and well, I will comment on the others soon. So hash-based value numbering, that can be done during translation to SSA form as a more general version of the copy propagation during SSA form. Then global value numbering is done when we have already translated the program to SSA form. Common sub-expression elimination and code motion out of loops, they are actually performed in a better way using partial redundancy elimination. So they are not needed in a modern compiler. So what is the idea of value numbering? Well, we take an expression and we give this expression essentially a hash table index. And this index is called the value, the value. The number of this value. Okay, so that's the origin of the name. What happens is that we save the value in a temporary variable, and then when we come to another occurrence of this expression, what we aim at is to use the previously saved value and use that instead, like this. This is a very old optimization technique, and there are implementations both on SSA form and before SSA form, and we will look exclusively on those on SSA form, since the others will not contribute any interesting knowledge for this course. So, an example. Here we compute A plus B, and then we recompute it into other basic blocks. And it's very easy to remove them, since, well, they have been evaluated and it's the same indices of the operands. Okay. What we will see here is a sequence of opportunities and sometimes not opportunity to perform this optimization. And the idea is that you will come to see which data structure is needed to perform this during translation to SSA form. Okay, so here we have the expression again, and here it is clear that we can reuse it. Here we can reuse the expression, but not here, since, well, we haven't computed it, since A has got a new value, and the same for this one. How about this? We compute A plus B and A plus B, but it's clear that they are not redundant, since neither dominates the other. So what kind of data structure can we use?